Thanks for coming to Tackling Unwieldy Projects with XP. I'm Peter Clowes. I'm one of the software developers at Savoya.
And my name is Joe Rodriguez. I'm a software engineer at Pivotal Labs.
Cool. Before we begin, we wanted to go over what we consider an unwieldy project. It's kind of an ambiguous definition. What we consider unwieldy is really anything where you're looking at the project and you don't really know what to do next, and you don't really see a clear path forward. This is a pretty subjective definition, and that's intentional. What is unwieldy for one developer, let's say with 2 years of experience, might be pretty straightforward with somebody of 15. What we want to make sure is that when we give this talk, it's applicable to a broad category of unwieldy projects. Before we begin, I also want to define XP. XP stands for extreme programming. It's a subset of agile development methodologies, which kind of has a silly name, but is really effective in practice. Before we go into that deeper, we'll just give you a background of what we'll cover. And so we're going to use our unwieldy project as the guide for applying XP principles to unwieldy practices in general. And so our unwieldy project was extracting, transforming, and loading data from a legacy software application into a new software application while we were launching it. And we want to show you why and how we apply these XP processes. I assume you guys don't really care too much about a single unwieldy project when you have your own unwieldy project to tackle. So we want this to be a happy, medium, agile process talk. What I mean by that is we don't want to stay fully focused on the abstract principle. We want to show it in its implementation detail and kind of continue to tie the principle to the practice and go back and forth. If it ever feels like, I'm not sure how this relates, we have a small group here, we're all friends. Feel free to interrupt. If we've lost you, ask a question. If it's a further detailed process question, save that to the end. We'll answer anything you might have. And we're also going to show you some interesting SQL. We did a really cool Postgres transformation. It's not really part of XP, but it is when you actually apply it in our case. And we also want to garner some sympathy. It was a hard project, so we want to show that. And also we want to show some technical side in a relatively non-technical presentation. Just to give you some background, I'll tell you about Savoya. Savoya is the company I work for. We're an executive ground transportation company. We do safe and secure ground transportation for executives worldwide. And what that means is we're online 24/7, 365. We work in about 60 countries, 60,000 airports. We always have somebody in transit somewhere. Most of our trips are in the US, obviously, New York City, LA, but we also do things in Berlin, Moscow, Juarez, the whole gamut. And we do provide services to 70 of the Fortune 100 CEOs. So our clientele is a little different. Everybody's like, oh, it's like Uber. And I'm like, yeah, like Uber if you're getting off a private jet, and if you wait 8 minutes, it costs the company several $100,000. It's a little bit different. Our mantra is, when it has to go right, use Savoya. And we all know transportation is seemingly simple from like a software perspective. It's like a textbook OO example, passengers, cars, etc. But it's hard in reality. It's a very difficult problem. I'd say about a third of us probably had some sort of transportation hiccup just coming to the conference. And those can really impact client relationships, board meetings, that sort of thing. So we kind of take that stress away from them. We're founded in 2000, so we've been around for a while. We know who our customers are. We know what our business line is. We're not a startup. We're not looking to pivot. We're kind of the small enterprise, if you will. Obviously, we still want to do more feature development. And we're based in Dallas, but the dev team is in Boulder, Colorado. And so we do have a off-site development team. And like I mentioned before, we had a 10-year legacy software application. And we've always been a tech leader in executive ground transportation. From flight tracking to threat assessments and that kind of awareness, we've always been the leader. But over 10 years, tech gradually accumulates technical debt, decisions that made sense 10 years. Hopefully we're not writing software the same way today as we did 10 years ago. And so over time, we kept running into these technical issues. It was a legacy Java application on an Oracle database. And to really enable feature development, the executive leadership decided to do a ground-up rewrite with a whole new dev team. Another thing that happened is some of the core contributor became independently wealthy through real estate investments. And we found out that having your senior developers become financially independent can have bad effects on your technology platform. So yeah, that brings us to our Pivotal Labs engagement. We decided to go with Pivotal Labs as kind of our guide through this revamp of our entire system. And that's where Joe and his team come in. Pivotal Labs decided to take this ground-up rewrite in Ruby on Rails with a Postgres database. And we wanted to build a whole new team. And originally it was just Pivotal Labs, and then they actually recruited developers such as myself to join the team, which is kind of where I come into the picture. During this, they wanted to bring extreme programming principles to Savoya. And so that's a whole agile mindset in general. It's radically different than the Savoya development process up to this point. We are used to 3, 6, 12-month development cycles. Every time you launch something, there'd be some regression. Typical, what I call like a bricked project problem. And so when we went on this, we had this challenge. Like I mentioned before, we're always online. We have extremely demanding clients. Things are moving quickly. Different private flights are coming in. You can't have our operators or our security specialists having 2 applications open to run them in parallel. The databases are totally different. And so we had to hot swap the systems. And then the executive said, we can probably do 5 hours of downtime before we really start to feel the pain of running this manually. We'll do it like really early in the morning on like a low travel day, and we'll just see where it goes from there. The key thing is, with unwieldy projects, whenever you get into them, there's always, from the outside, they always really appear simple. You just simply have more developers. You just simply start testing 6 months earlier. You're kind of constrained by real world time, money, and resource issues. While those are really, really valuable pieces of feedback, we want our presentation to focus on, okay, you're kind of between a rock and a hard place. How do I lean into XP principles to get me out of this sticky situation? And for us, beta testing wasn't really an option. If we tell a CEO of Fortune 100, we'd like you to beta test our next ground transportation software release, they're kind of like, that's great, I'm going to use your competitor, and that'll be the end of that relationship. So we did have a kind of a do or die moment, where it's like, you're going to do this big commit, and it's kind of, if you fail too hard, it's time to tune up the LinkedIn profile. It's one of those situations. And so when we first decided to do the extract, transform, and load of the data from the legacy application into the new application, we tried it ourselves. We kind of have our story in pictures on the right if you want to follow along. And one thing to keep in mind is we purposely did not know anything about the legacy application when we built the new application. And that was intentional. We didn't want bad patterns from the legacy application informing design decisions and architectural decisions in the new application. As a result, the applications function fundamentally differently. And the other thing that was a complicating factor is we had no concept of how the data actually flowed through the legacy application. The objects are roughly the same, reservations, passengers, vehicles, but we didn't know how it was organized or structured when we built ours. And so the database tables were not one-to-one mappings. And I think that's a hallmark of every unwieldy project. Typically, it's a lot of uncertainty. You're just kind of like, I don't know. And we're going to try and show you what we did wrong and then how to not do that on your unwieldy project. The other complicating factor was a lack of context in terms of actually knowing Oracle databases in and out, or we didn't have like a database architect or administrator, and we didn't have any SQL experts on the team yet. And so we kind of took the wrong approach. We're like, okay, there's a lot of uncertainty here. Let's start with our most basic relations and kind of build up from these really simple tables and go forward. And the problem is, since the databases were so different, what was simple in our system was complex in their system. And so you kind of are like, oh, simple table, simple mapping. Go to that database and you start pulling it, and you're like, oh, that in their system, it's actually relational with this other object. So you pull in that object and you realize, oh, that object in our system's actually up here. So then you start e-tailing all that stuff, and you kind of end up with this tangled ball of yarn in your hands. And this was really frustrating. Really simple transformations would get really complex. And this caused a lot of issues. It really throws a wrench into your typical development cycle. It makes iteration planning hard. You know, you're in your iteration planning meeting and you're forecasting the stories and you say, how long is this going to take? And after you've been burned once or twice by a simple story snowballing, you're kind of like, I don't really know. And then we're a small development team. Even today, we have like 4 developers contributing to the project. When we were at Pivotal, I believe we were at 6 was the high watermark. And if you have one thread of work working on ETL and another thread of work working on feature development, because the plan was to have all the features done for launch roughly done at the same time that the ETL was, and the feature development hits a complex feature, and the ETL team hits like a nasty transformation, all development's blocked, which is really discouraging. There's a psychological component there, and I think that's also true of all unwieldy projects. Just because you're kind of in the unknown, you have product owners being like, why is this different? Like, why are we told, like, no bugs are getting fixed, you know, no progress is feeling like it's made. And so we decided to engage a third-party database expert team that had done ETL before. And the rationale for this is really straightforward, is you just say, well, we have features to build, we're not experts at this, we'll go with this other team, they'll do the ETL, they've done this before, and then we'll you know, hopefully arrive at the same time. And while this was a totally, you know, reasonable answer to the problem, it was actually completely wrong. And why it was completely wrong is it really didn't fall in line with the XP principles that we'll cover. It was, yeah, it was, we'll get into it, but I'll let Joe take over that one. But what happened is when you're not put in a position to succeed, the hard things that are hard suddenly become really impossible. And the first one of these was the team wasn't co-located. You don't really realize like how much information is shared between Joe and I. Even though we work for different companies, we're working together in the same office, we're getting lunch, we're talking about software. You know, you start getting a feel of how people think about code, and the non-co-location was really detrimental. The other issue is the big problems always seem to stay big. You know, we tried at first attacking the little problems in our unwieldy project, and with this database team, we're like, okay, now we tackle the big problems. And so you'd have this lack of progress. You'd say, okay, we have in a reservation, you get picked up, and let's say you get taken to the airport. So you have a pickup location and a drop-off location. Those, most of the time, are different locations. You're generally not going in circles. Somehow, we had this constant problem where due to the data structures, we'd have pickup be inserted into our system as both pickup and drop off. And then we'd get that fixed, there'd be another little bug, and then that would suddenly be broken again. So you'd have these like regressions. And what these regressions did is they caused these anti-pattern feedback cycles. And what I mean by that is, I'm sure you guys had this experience, like something goes wrong, people are like, okay, let's kind of have a post-mortem and let's see what's going on. You get in this talk and you go about process and you think it's okay, and like a couple weeks later, like something else happens and you have an even bigger meeting about that, and that kind of snowballs. And not enough questions were being asked by either the ETL team or ourselves. And there was a lack of like mutual ownership of this, you know, and I think that was a big part of not being co-located. In hindsight, this whole experience, it's kind of like a science experiment, right? We tried it ourselves one way without XP. We used another team. We kind of have these two comparison values to compare to our final solution. And now we kind of want to take you through the basics of extreme programming, and I'll have Joe come up and guide you through that.
Yeah, so extreme programming. You may or may not have heard of this before. It's not used by a lot of development shops. Solely extreme programming. Pivotal Labs is a XP shop. A lot of companies that are doing Agile will pull in some of the practices that came out in the early 2000s from extreme programming. Hopefully you were at, hopefully you were able to see Yancy speak. He talked a little bit about some of these, and we're actually going to talk about just these first three here. And there we go. Oh, this is not on. Cool. So yeah, these first three, test-driven development, pair programming, rapid iteration, we would love to talk about all of them, but I think we would really have to do a workshop if we're going to be able to cover all of that. But the good news is we're going to cover these three. We're going to show specific examples, and hopefully if you haven't tried these, or if you had tried them in the past and they haven't quite worked right, maybe you can take them back to your place of business and give them a shot, because I think they were pretty crucial to our project. Yeah, so Onsi actually talked about these when he talked about pivotal process, but he didn't mention extreme programming by name. So just a little bit of that here. Test-driven development, this one was huge for us. Why did we test drive? You may be thinking, this is throwaway code. We're only going to run it once. That's definitely true, but it is high risk. So if we make one small mistake in our ETL, that's going to have a pretty big negative impact on the business because it's just that one shot, that one chance that we get to run it. So we wanted to sort of mitigate some of that risk by test driving all of our ETL code. Prevent regressions. So Peter told you the story about pickup locations, these types of regressions. We definitely wanted to avoid doing that kind of stuff, and test driving, in my opinion, I think there are probably opinions that are differing, but in my opinion, that makes a huge difference there. And so clarity of code. Like I said, we used, we'll get into some of the SQL, but we had to do a lot of data exploration to find out what our requirements were. So having clear code helped us to easily deal with these changing requirements. By that I mean, we wouldn't know what we wanted to do unless we looked at what type of data we had in the old system. It's like, oh, this note field popped up. Hey, product owner, should we just like drop this on the floor and leave it, or should we actually do something with it? He's like, yeah, well, we definitely want that data. We can go back to the tests that we already had to migrate, for instance, our reservation table and add to those tests to make sure we're picking up the notes there. Before I show you an example of what our sort of test harness looked like for our ETL code, I wanted to go over some interesting findings that we had in the legacy database. This one's pretty cool. So here we're just selecting from this note table in the old database. We're trying to get the value field and parse that to XML. So it's XML stored in the database. It's a bunch of notes. But when we ran our tests against the real legacy data, we kept getting this error, update note set value, this syntax error. And we were like, what is going on? For 15 or 20 minutes, we didn't run an update command. We're not trying to change notes. Where is this coming from? So this error is actually coming from trying to parse the XML. It turns out that the legacy database actually had this value inside that column. So you see, it's not XML. There's actually an update statement in the database. That's not going to be parsed by XML. So that was interesting. Another thing which was common at the time and still common in lots of data stores, storing many statuses in one flag using bits. So just turning one bit on means the reservation's confirmed. We had no idea what this meant, and we asked for sort of like a list of these op status, this column here, to see what the different values actually meant. And we got a spreadsheet back with like 15 or 20 values and then like a reservation status next to it. But when we did a distinct on this column, there were hundreds of distinct values for this field. So we're like, okay, something else is going on here. Lots of stuff is being stored in this one column. So we asked for the source code so we could just sort of figure out. And they sent us the legacy team sent us a WAR file. Not source code. But that's okay. We didn't go back and ask again. We just decompiled the WAR file, found a reservation status class, and that had all the information that we needed in there. So it turns out in the left, from the 5th bit to the end, that bit shift right there on our op status, if the 8th bit was turned on, that means the reservation was confirmed. So there are 20 or 30 of these statuses, and also in the first 4 bit positions, there were different types of statuses being stored. So that was, if we didn't get that, I don't know how we would have done it, but I think eventually we would have gotten the source code or got someone to come out and show us. But it's pretty cool that we were able just to decompile it and see exactly what was going on. All right, so let's look at a concrete example of how we test drive the ETL code. So I have source on the top here. So sort of what a reservation op status looks like in the legacy database. And then below our reservation event table, basically what they were storing in one column, we wanted a list of events for in a different table. And we stored some other stuff here, like when the event was created, so we can go back and audit and see what happens. So in this case, if the op status is 209, blah, 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 we want these 3 events: created, confirmed, and in transit. So how did we set up our test for that? So I'll give you a quick second to read this. Grab some water. So if you've test driven in the past, this should look pretty basic. We have our 3 main sort of sections of the tests: arrange, act, assert. So arrange, insert data into the legacy schema. We were using everything in Postgres. We had transferred from Oracle at this point. Peter's going to talk about that a bit more. But we had everything in the same database. So old data and what our new data look like in one database. That just made it a lot easier to run the transformations. So yep, the first step again, insert the legacy data, and then we'll run, this is our act step, we'll run our actual service, and then we write an assertion to make sure that for this reservation, these 3 events get created. So pretty simple and straightforward, right? But it actually wasn't so obvious to us at first. We write a lot of application code, and we knew that we needed tests for ETL, but once we came to this conclusion, we felt really great about it, and it felt obvious. But first, we tried smoke tests and some integration tests, and those just didn't actually work that well. We did have another set of tests, but I think most of the value came from these unit tests here for these ETLs. And yeah, so I guess what we learned here is definitely put some time into developing a test harness for your project to see what works, even if it's just not simple application code. If it's a one-off or a different type of project, put some thought into building out a test harness that works for you. Also, I guess we were tempted to sort of stray from the process and say, hey, we don't need to unit test this thing. We're only going to run it once. I think it was pretty important that we did this. We definitely saw the benefits by the end of the project because we saw how many times we were revisiting these same classes that ran the ETLs. So don't be tempted. Stick with your process. All right, Peter's going to tell you a bit about how we did rapid iteration on the ETL.
Yeah, and like Joe was saying, with test-driven development, that really is the foundation for rapid iteration. Without the TDD, we really wouldn't have been able to move quickly. And so you have this agile principle of small releases. And well, that's great. It doesn't really apply to like a one-off event. So you kind of have to take the principle and mutate it a little bit. And we wanted to go back to the practice of rapid iteration, of how do we get constant feedback in this complex domain. The testing was really helpful here because every time you run a test, you're basically making a hypothesis that you understand what you're doing, and you get constant feedback if you're off course. And that really allowed for like a reinforcing feedback loop as we went through these rapid iterations. How we were able to do that was we would constantly have real, actual, up-to-date data that we could see ourselves, give to testers, and get feedback on. And we were able to do this with multiple pushes a day, so we could really kind of crush through stories. Bugs would come up, you add a test, you push the code, and you get feedback within hours instead of days or weeks like the other ETL processes we tried. And one of the keys that we did was a dedicated environment for testers. We actually spun up a whole new instance that was just running on the data we're ETLing, and we turned people loose in there. And I think that's true with all unwieldy projects, is you want to mimic the real situation that you're trying to accomplish as quickly as possible. So get it into a test harness and then get it into as close to a live production system as you can, even if it is a one-off event type of project. And what we did here is we tackled the complex things early. So if you remember in our first time when we tried this, when we failed, we went and we started with these kind of simple objects and tried to build the structure up from there. In this one, we said, hey, let's start with the most complex table. And there's other XP principles that address this, but we won't get into those in this talk. And what that meant is our reservation object. That's kind of our God object in the system. That's the one that always tries to tightly couple with everything else, and you have to really fight to keep it loosely coupled. I think in the legacy system, we had a reservation table with over 200 columns filled with the kind of data that you saw there. And there's many relationships there. So what we said is like, hey, if we can't ETL reservation, like we're in trouble. We don't need to, we'll get feedback faster if we know we can't do this. Vice versa, if we can ETL reservation, we're probably going to be able to ETL everything. And so we went after that one first. And so this is a simple example, but on this one we have the coordinator and the driver and reservation. They both belong to the reservation. And so what we did is we faked out this data. We just said, we injected a dummy driver. We set their ID to 1. Every time we ETL the reservation, we weren't worried about drivers yet. We just, in our system, driver ID 1. And this allowed us to go into one script. And this was really important because that means you have a single script that everybody can go through on the team. It was a bash script broken up into steps. You just run it, execute, and the whole ETL process happens. The only difference that happened when we actually launched this thing, it was we were running it against our production instance. So it was as like close to live fire scenario as we could get. And we'd also get feedback through each step. We'd benchmark it to have time because we had that 5-hour window. And that way we'd know if we did a really bad join that was chewing up a lot of resources or one part of it was slow. And so we'll just take you quickly through the script. We won't get into the nitty gritty. It's not that important. But it is a way to just do your unwieldy project. Should be encapsulated in either some documentation, a script if you can, trying to think creatively about how to do the whole thing end to end pretty simply. And so you have a database on a foreign server, and you just have to grab a dump of that file, really straightforward. And then what we decided to do is restore that dump to a local virtual machine. With Savoya, we don't have hundreds of millions of clients. We have a very select few. So we're not dealing with big data or anything. So this was a decision that we made to speed up our process time, just because we could run transformations much quicker locally. That might not be applicable to big data projects, obviously. So we had that in the VM, and then we used this really cool library called Aura2PG to move the DDL from Oracle into Postgres. And then we used a really cool concept called foreign data wrappers, which is an attribute of Postgres. Joe will talk more about this later, that allows you basically to pull in foreign data structures and pull them into your database. So then you're kind of dealing with a database that is at least of the same kind as the one that your final destination database is in. And then you run the transformations. And this is kind of the meat and potatoes of moving the data from one database into another. And Joe will show you some cool SQL around that. And then simple Postgres dump file, load it to our server, hit restart, and you're live. What's really cool is this allows us to fundamentally alter the software a client is using. Let's say we drop them off at the airport, they get on their private jet, they're flying, and when they land, their software is completely different. That was really cool. And so Joe's going to go over some of the benefits we saw from co-located paired programming.
Yeah, so we paired exclusively on this project. Pivotal does that with a lot of projects. And I think it really worked out great on this project because we had people with a strong SQL background pairing with Savoya developers like Peter, who had a strong business background and knew how their new app worked, knew a little bit about the old app. But yeah, mostly knew how the business worked, the new domain, the new schema. So we were able to transfer knowledge by pairing to each other. Like I would teach something cool about SQL to Peter, and he would say, hey, this is how Savoya works. This table is structured like this. This data needs to go from here to here. And it was fantastic. Also to reduce defects. So along with TDD, we wanted, it's not like we're searching for high quality code because this is throwaway. We run the ETL and it's gone. But the reducing defects was huge because like I said before, if we made one small mistake, it would have a real negative impact on the business and the clientele. Also a safety net. This is one of the classic examples of why you should pair. You don't want to create, you don't want to pigeonhole or create knowledge silos. So you want strong rotation and pairs swapping hopefully every day or every couple days and really transfer knowledge about different parts of the our ETL process and transfer knowledge about SQL. And if someone's out one day, or if they're on vacation, or at Pivotal we rotate projects a lot. So if someone gets taken on off the project and moved to a different project, you're not really going to run into issues. And I think one thing that was great about this is, and Peter can attest to this, but by the end of the project, developers that didn't have as strong of a SQL background felt really comfortable, and it made their application code a lot better by gaining those skills. Yep. So I guess, yeah, what I want to show you related to pair programming is some SQL. But first, why did we use Postgres, and why did we do this in SQL as opposed to doing this in like Java or Ruby or Python? Well, the obvious reason is Postgres is our destination data store. So why not do it in Postgres and then dump it and put it back up to the database without having to transfer it to a different database or different type of data store? We're as close to the data as possible. So this is sort of like the lowest level tools that you have for working with the data. The Postgres tooling for data transformations and the built-ins that Peter talked about, like foreign data wrappers, they are available in other databases. But foreign data wrappers were huge for basically doing a select star, I guess it's like an insert select query from a foreign database into our Postgres database. We've dealt with a lot of XML, right, is some examples that I showed you. I'm going to show you more. So the XML support in Postgres is good. Mostly taking XML that was in the old database and not using XML or JSON or serializing any data structure in our new database. Speed. So we actually did do a couple of the initial transformations in Ruby. So we would write a script that would loop over all the records in the reservation table and then figure out, what the new reservation would look like. But you would have to query a bunch of old data, and the code was like 200 lines. It was huge. It's not declarative. And it was really slow. It was one of our bigger tables, but it just wasn't going to fit into the 5-hour period. Once we started writing all this stuff in raw SQL, we were able to test faster, we were able to get things into our testing environment way faster, and we're able to totally sort of kill that 5-hour time limit that we're looking at. Readability, I don't know if everyone will agree with this, but certainly for me, it's a lot easier to look at 10, 15 lines of SQL than 100 lines of code. I'm not saying that all of our SQL was fit in 10 or 15 lines. I think we had some that was over 300 lines. And that wasn't just 300 lines of column listing. That was like 300 lines of transformations with dozens and dozens of subqueries and common table expressions. So with that, let's take a look at how we ETL'd passengers. So similar to notes, passengers were also stored in XML inside our reservation table in the old database. We did not want this in our new database. This isn't how the new app was designed, thankfully. So the destination, what we're going to is this reservation passenger table. So taking stuff out of XML and putting it in a different table. Fairly simple in Postgres. I'll let you take a look at this, and then I'll sort of go over how it works. So if you haven't seen this with clause before, this is a common table expression. By far the easiest way to improve the readability of your SQL and to do more than you thought you could in sort of one block of SQL. It basically allows you to create this temporary relation and store it in this passenger object's, I'll call it a relation, I don't want to call it a variable. And then you can go on to use that in any subsequent SQL. So this allows you to write one query with like your basic source data and then keep iteratively massaging it until it looks like your destination table, which is exactly what we did for a lot of these transformations and mappings. So yeah, we get our source data here. XPath allows us to get all the passengers out of the XML. Nest is really cool. It's a Postgres function that takes an array of data and sort of produces a row for each member of that array. So if we have 3 passengers inside this reservation, instead of getting an array of these passenger XML objects, we would get 3 rows, 1 for each object. And the reservation ID there will stay the same for each one. So it's sort of like the Cartesian product of that array. So once we have that passenger object, we then can extract the first name here. I don't know if you can see that little duck with some more XPath and getting the text out of that node that we just looked at here. And yeah, that's part of this transformation step. So basically, you keep changing the data until it looks like your destination. And then finally, very simply, we just insert into our reservation passengers table. That's our destination table. So that's actually not what our database looked like. We didn't store the passenger again and again for each reservation. We have a passengers table. So a join table in the middle. This is a bit more complicated. In the old database, everything was stored in a reservation. In the new database, we have 2 destination tables. And you could do this in 2 steps, but you introduce a chance to join against the wrong data. So we wanted to do it in one big query. And common table expressions actually allow you to do this. So we can, here's the source table again. And this is what we want. So we need records in 2 different tables as the output of this transformation. And so how do you do that in one query? This is very similar to the last query, but you see 2 insert statements in this query. So in common table expressions, you can insert multiple times, and you can also return the data that got created. So now we actually have access to the passenger ID that we need right here. This ID isn't created until it gets inserted into the new table in Postgres. So here we're able to, just to recap, insert inside of a common table expression the ID, the name, all the data that got created because we're returning star. All the data that got created inside of this insert is now stored in this relation. So we can use that relation to insert into reservation passenger. There is a bit tricky thing here that I left out. You do have to somehow reconnect those 2 things back together to get the reservation ID and the passenger ID matched up. So that's where we do a join here. Not sure if there's a simpler way to do this, but that worked for us. All right, that's it for the SQL. Peter's going to tell you a bit about launch day now.
Yeah, definitely. And with that SQL, it's kind of, we just thought it was interesting. Plus, we wanted some sympathy for the nasty data we had. What I really want to emphasize is how important the XP principles were in our unwieldy project of driving out those more elegant solutions without using TDD, co-located pair programming, and rapid feedback cycles. We probably would have implemented those in far more ineffective ways. I learned so much about SQL and just optimization there. Highly recommend it for your unwieldy project as well, which kind of gives us, the victory lap part, right? So you have launch day. We launched February 13th at 2 a.m. Mountain Time. My wife loved it. Valentine's Day the next day. It's always ideal. We did it in 2 hours, so we were well within our 5-hour time limit. And I think this is really important, is whatever metric management kind of gives you on your unwieldy project, you want a large buffer. Things kind of just go south. Just in some dry runs, we had all sorts of little issues that we ran into. And I think that also highlights the importance of having your whole unwieldy process, whatever yours is, in one central place, in one team that's cross-trained on all of it. Anybody can run it. You can easily adapt. And then when it's actually go live time, you're ready to go. And so over the next 24 hours, we had a lot of issues. Right? Shocker. There was all sorts of little data that wasn't quite right. Like, this guy is traveling with his child. Turns out child seats are a huge deal in ground transportation because there's always liability issues. I never would have known that. And so we were doing on-the-fly data adjustments to our newly minted Postgres database. And so we would do queries into the old database to pull that data over. And at first, this kind of sounds a little frightening, just because now you're injecting things into a system that's running. But what we did is we just followed the same XP principles that we learned and how to apply them when we were doing the ETL itself. And it was actually really straightforward. After that, we flew to Dallas to kind of be next to our team. And that was really important, that co-location, not just with programmers, but actually with the people who are running the system, your internal clients, if you will, your external clients, some of our vendors, and management especially, you kind of get like a pulse. Like you can kind of hear the phone chatter pick up in an area of the office and you realize, oh, something's going south. And then you can also they see the solutions faster. I think it's really important for team chemistry. Unwieldy projects don't ever just impact the engineering organization. In 2 weeks, we were completely stable. Which was really great. I think by Thursday of the launch week, we were enjoying steak dinners in a park by the office, and the picture there is a nice champagne toast they gave us after that. And there was a couple big things that really came as a result of adopting these XP principles. Is XP really allows you to have trust on unwieldy project land. One thing I always see when you have these unwieldy projects is everybody is a little hesitant, a little scared. Things where you're normally like, oh, they've totally got it. It's always like, are you sure you got it? And this really demonstrated that. Like I said before, we were developing on 3, 6, 12-month timeframes, and now still today we can push 5 times to production in a week, no problem. So we can move really fast. And that allowed us to have a lot more trust from the product owners and the CTOs and the CEOs that like we had their back, and they also supported us. And if you're going to try and introduce XP principles during an unwieldy project, I highly recommend. Actually, there's no way it's going to work without executive support, and so you have to make sure your product owner's on board. And ours very much fully bought in, and I recommend that as critical. And this whole agile mindset has continued to transform the organization. Velocity has continued to climb. We've rolled off of Pivotal, I think since March, April. Hired some more developers. We're going faster than ever. Have our own dev team. It's been really great. One thing we have is we have some more resources for you guys. Obviously, extreme programming. That's the most simple one. And then the second one down, this guy right here. This is a more deeper dive into our ETL journey, written by 2 pivots from Pivotal Labs. And then there's some more stuff on some of the cool little nerdy SQL tools we talked about. At this point, we'll open it up for questions. Yeah?
Were the issues you encountered after your launch day related to things you just not accounted for in the unit test, or were they related to was you putting software or something?
Let me make sure I understand your question. So you were saying the issues post-launch, were they, things we couldn't caught in our unit test, or I'd say they were mostly business related things, or really one-off pieces of data that we never saw. That one reservation out of like 100 where they go on a private jet to an airport, they pick up somebody else at an airport, they have the meeting in the car, they get dropped off at the same airport, and it's like really convoluted. You don't really notice those even through all that testing. It's really hard to cover every business edge case. So I'd say, yeah, there were gaps in our unit tests.
Yeah, and I think most of the issues that I dealt with were brand new piece of software for the business, lots of things they weren't expecting. So most of the changes weren't related to the ETL as far as I remember. A lot of them were like, hey, this isn't working as we're expecting, or this accounting number, doesn't match up.
Cool.
Anything else? Nope. All right. Well, thanks everyone for coming. Appreciate it.